Alrighty, so after we finished the lesson on Wednesday, I told you that you should, because 6.1 and 6.3 are together, you should have been able to do problem 1 and 6, because that was either by substitution elimination, right?
On the math lab?
Yes.
Oh, I didn't do any of it. You said there wasn't any homework on it.
There was no homework, but I did say, I think, that you could do those, because I had one or two people
I didn't
do
even
it.
open up my math.
It's okay. You're like, oh, I just have this worksheet. It's all good.
Because it is different points. Good.
Matrices and systems of equations. We're going to start doing this by a 2x2, and then we're going to go into a 3x3. All right. So the first thing we need to know is, still using the main problem we used last time in our notes that we solved all 3 different ways, is when they give you a system, you need to change it into a matrix. When you do that, the only thing you care about is your coefficients. And your coefficients are the numbers in front of the variable. So the number in front of x is
1.
1. A little space, the number in front of y is -1. And the number that it's equal to is 5. Now, who's your coefficient here?
2.
2.
2, 1.
Who's the coefficient there?
1.
1. And then we have a 1. So we are putting your coefficients, a line that goes straight up and down, and then what they're equal to right there. So this is a matrix right there. Now, if they were to ask you for the dimension of the matrix, this is row by column. How many rows do you see in this matrix?
2.
2. How many columns do you see in this matrix?
3.
3. So in case they were to ask you, hey, what's the dimension of it? Oh, it's a 2x3. If they were to ask you. Later, we're going to be using it maybe in 6.4. Now, we're going to do something that is called Gaussian Elimination. Now, in Gaussian elimination, there's 3 things that you could do.
Is that IAN or ON?
IAN. Gaussian elimination. The first thing that you are allowed to do is interchange rows. And I'll show you what that means in a little bit. The other thing you could do is multiply each entry by a non-zero constant. And this you do when you're trying to get a 1, and I'll tell you exactly what that means in a little bit. And the third thing you could do is add a non-zero constant of one row to another. Now, there is Gaussian elimination, and then there's Gauss-Jordan elimination. So I'm going to show you the difference of both. When you do Gaussian elimination, and you have something like this, we're looking for a 1 here and a 0 there. There will be a number here and a 1 here, and you will have numbers and numbers there. If it's a 3x3, which we're going to do before you leave, it's a 1, 0, 0, 0, not 0, just kidding. There's a number up here. Number 1, 0, number 1, number. And by the number sign, it means it's just going to be some random number. A random number that will give you the answer, but I can't tell you it's going to be a 5 or a 6. Now, we have another one called Gauss-Jordan elimination. And then this one, we have that. Whoop. Thank you.
Mhm.
So, do you notice a difference between Gauss elimination and Gauss-Jordan?
There's no number signs on the left side.
Very good. So, your ones are in a diagonal, and both, right? But diagonal bottom left, zeros, diagonal bottom left, zeros. When you do Gauss-Jordan, there's a diagonal of ones, and everything else is a what? Zero. If you go this far, whatever number you have here, you're telling yourself x equals to this, y is equal to this, and z is equal to this. X equals this, y equals this. But when you take it this far, you still need to do a little bit of work. Now, we're going to do both. Once we get to the 3x3s, we're going to stop here possibly, but you can still take it this far. It's up to you. When you do your assignment on my math lab, they say either do Gauss elimination or Gauss-Jordan. Alrighty, so our goal right now is going to be to make this look like this. Make that look like that. Are you ready? I'm going to turn the page. We're going to try. So be open mind about what we're going to do. So before we get started, you know what? Let me put it up here because these are extra notes that we should do. Make the one of each column first, then make the zeros of that column. To make a 1, you multiply by the reciprocal. So you make the 1 of each column, then you make the zeros of that column. To make a 1, you multiply by the reciprocal. To make a 0, multiply the row with the 1. And you'll know what this means in a little bit when we read this over and over when we're doing the actual work. So make the 1. To make a 0, multiply the row with the 1 and add it to that row. And add it. So I didn't explain this in my morning class, but I'm throwing it out there because I think it would be helpful. And maybe we'll come back and change the wording so in case it makes sense. But once we actually practice the problem, we'll see if it actually works or not. So make a 0, multiply the row with the 1 and add it to that row. You want to make a 0? Sorry. Because it kind of sounded like you were adding it to the one with the 1, but you're not adding it to the one with the 1. All right. It's going to be okay. I believe. Say it.
I believe.
Okay. I believe math is gonna kick my butt. No, I'm just kidding. So here we go. Example number 1. We're doing 2x2s. And this is the first problem. X negative y equals to 5. 2x plus y equals to 1. So the first thing you do is make it into a matrix. And remember, your goal right now is to make this look like that. That's your first goal, to get that Gaussian elimination. So I'm going to take this and do this. 1, negative 1, 5, 2, 1, and 1. So I just took this, made the matrix. That's it. 1, negative 1, 5, 2, 1, 1. Are we okay with that?
Hold on 1 second.
Holding on.
Going too fast. Is that the y?
Negative 1. So this has a 1 in front, this has a negative 1, this has a 2, this has a 1, that's a 5 and a 1. Okay? So what we wrote first was make the 1 in each column first. So is there a 1 in this column? Yes. So you first work with column 1, make the 1 in the zeros, and then you move on to column 2, make the 1 in the zeros, and then to column 3 and make the 1 in the zeros. You always go in that order. So this guy's already a 1, so I don't have to worry about making this a 1, but I have to make this 2 a what? A 0. Remember, it has to be 1, 0. This is a 1, this is a 0. I have to make this a 0. If I have 2, the only way I can make 2 a 0 is by subtracting 2. But you can't go and subtract. So if you remember the other one, it says to make a 0, what does it say?
Multiply the row with the 1.
So I have to multiply row 1 times something. What can I multiply 1 times to get rid of this? A negative 2. So I have to do negative 2 times row 1 and add it to that row that you want to make a 0. Which row do I want to make a 0? Row 2. This is going to give me my new row 2. So once again, write that down, and then I'm going to hit it again. We're trying to make this 2 a 0. So it says multiply row 1, where the 1 is at, by a negative 2 and add it to row 2. So does row 1 change? No. Who's the only one that's going to change? Your second row. So this is what we're doing. This negative 2, yes, times, who's in my row 1 right there? A 1, plus my row 2. So look up here, and then I'll give you a chance to write it down. Row 2, this negative 2 is there. Who's in my row 1 right here? Negative 1, plus who's in my row 2? 1. Negative 2 times 5 plus 1. Now, you told me we're not changing row 1, correct? Because the only math we're doing is in row 2. So I'm going to rewrite row 1, 1, negative 1, and 5. If I could do these calculations, so this is showing the math to doing that.
I'm so lost.
Yeah.
What's negative 2 times 1? Plus 2?
0.
Did I get the 0 I needed? Yes. What's negative 2 times a negative 1? Positive 2 plus 1? 3. What's negative 2 times 5?
10. Negative 10.
Negative 10 plus 1? Negative 9. That's negative 10 plus 1 is a negative 9.
Why is it? The numbers that you,
Negative 2?
that, all of that right there on that side. I get them.
You get what part? This part?
I get the
You get
math
this.
that you did that. It's that I'm not getting.
Well, this, I just copied that. Since we didn't do anything to row 1, boom.
Okay,
I did the math
-2,
here. I did the math here. I did the math there.
Yes, the -2 times 1 plus 2. Where did all of that come from? That's fine. I know that Kate.
Negative 2, negative 2.
Okay.
Who's your row 1? 1. Who's your row 2? Row 2. So negative 2 times row 1 plus row 2. Negative 2 times row 1 plus row 2. Negative 2 times row 1 plus row 2.
Okay.
Negative 2 times row 1 plus row 2.
Okay, can we write that down?
It always be the same if you just take the row, multiply by 2, and then you add the second row. Instead of doing it that way.
Like do the multiplication then add it. So when you would multiply it, they always teach it like do both operations in one. Do the multiplication and the addition, multiplication and the addition in one.
So is that the answer? No.
That's just one step.
You still have to make the
Oh, yeah,
bottom
all
right
this
one,
stuff.
right?
Very good, Dane. So Dane says we still need to make the bottom right a 1. So I need to make this 3 a 1. And if you saw it says to make a 1, you multiply by the who?
Reciprocal.
Reciprocal. Who's the reciprocal of this 3? Because it's the 3 you want to change to a 1. So it is a 1/3. Very good. So I am going to take what row and multiply it times 1/3?
Second.
The second. So it is a 1/3 times row 2. Once again, why are we multiplying row 2 times 1/3 to make this a 1? Because the rule says to make a 1, you multiply by the reciprocal. So am I doing anything to the top row? No, right? So I am not writing anything in the top, not writing anything in the top. So I'm going to do 1/3 times row 2. Who's in your row 2? 0. 1/3. And please do not go back to this. This is your new matrix. You go to the one previously done. 1/3. Who's in my row 2? 3. Align. 1/3. Who's in my row 2? Negative 9. So, did I do anything to row 1 in this problem? No.
Where did you get the 1/3?
Reciprocal of 3. Because the notes we wrote at the beginning, to make a 1, you multiply by the reciprocal. The reciprocal of the number you're trying to make a 1. So 3 over 1 becomes 1/3. So we didn't do anything to the top row, so it stays the same. We're not doing anything. 1/3 times 0 is 0. 1/3 times 3 is 1. 1/3 times negative 9 is negative 3.
And that's the final answer?
If they said if you had to only do, but this is the thing, that's the answer, but that's not the answer. Please understand this represents who? X. So I have X minus Y equals to 5. This represents who? Y equals a negative 3. So I already know who Y is because I took it that far. How do you find out who your X is?
Plug it in.
So I get X minus a negative 3 equals to 5. X plus 3 equals to 5. Minus 3 minus 3. X is what? 2. So my answer should be 2, negative 3.
So it's a coordinate.
Yes, your answer is going to be a coordinate at the very end. So every time, unless you get an infinite mini solutions or a no solution.
So why did we use elimination? Why use this then?
It's the same thing. Why not use elimination? Because they want you to do it this way. They want you to know that you could do it this way also. You know, why buy a car and drive it when you could walk to work? Why?
It's easier.
It's easier. Well, this is making your life harder.
So we're just basically selling farm walking instead.
Yeah. You should be able to do it every way. You should be able to do it through substitution, graphing, elimination, and now either Gauss-Jordan or Gauss elimination. Now, I'm going to use the same problem, but finish solving this through Gauss-Jordan. So we're going to continue to Gauss-Jordan. If you understood 1/4 of what we said, that's a gain. We're going to still do 2, 3, and then I'll let you do one on your own. But you need to just like not freak yourself out.
I didn't even understand that 100 of it. I am so lost.
Okay, did you know how we got from here to here? So don't tell me you only understood 100s because that is more than 100.
Okay.
Okay, all right. So we're good. Now, to do Gauss-Jordan, the goal is for this, yes, where you only have zeros and ones right there. I'm going to continue from this guy here. So from this guy, to make it look like this, what is the only thing that you're missing?
Zero.
A zero up here, correct? Now, what do I have to add to this to make it a 0? A 1. So it is going to be 1 times row 1, times row 2 plus row 1 is going to give me my new row 1. So I know when you multiply something times 1, does it change?
No.
No. So row 1, blah, blah, blah. 1 times row 2, which is the bottom one, because who has the 1 in this column?
2.
Right?
2.
Thank you. Row 2 has the 1, so row 2 we're multiplying times 1 and adding it to this. So which row does not change?
Row 2.
Row 2 is not changing. Good. So up here, this 1 times row 2, who's in my row 2?
0.
The 0, plus my row 1, which is a 1. 1 times row 2, who's in my row 2?
1.
1, plus my row 1, which is a
-1.
negative 1. 1 times row 2, which is a negative 3, plus my 5. Now, that's the math. The answer comes when you calculate it. Now, who did not change?
Row 1.
Row
Was it 2?
2. So this is 0, 1, negative 3. We didn't do anything to row 2. We're not adding anything. We multiplied, but to add it to the other one. What is 1 times 0?
0.
Plus 1? What's 1 times 1?
1.
Minus 1?
0.
What's 1 times negative 3? Plus 5?
2.
2. Now, this is 1, 0, 0, 1. Is that what we were looking for? X equals 2. Y equals negative 3. So what is the difference between Gaussian elimination and Gauss-Jordan? When you do Gaussian elimination, you still have to play with your variables to find the answers. If you finish this all the way, there's your answer, you're done. You don't have to be doing any more x equals x plus y equals blah, blah, blah. You get the same answer. Same answer.
So I understand when it says 1 times 0 plus 1.
Give me a second.
I see that, but then where's the 1 times 1 plus a negative? Well, where?
All right, so another 2 by 2. You got a 2x plus 1 equals to 1. 3x plus 2y equals to a negative 2. So the first thing is you make it into a matrix. So let's go ahead and do that. All right, so what's our goal?
To
Our first goal is to make it look like this. So to make who, yes.
Okay, so whenever you use the Gauss border, do you only start using that method once you are done with the first one?
You need to be able to do this before you go to the Gauss order. But once you finish Gauss elimination, you could do it by hand or finish doing the whole row multiplication thing and finish, and it gives you the answer at the very end. You have that choice. So the first thing we do is make who a what? Make the 2 a 1. And we said in order to make a 1, you need to multiply by the reciprocal. Who is the reciprocal of that 2?
2, 1 over 2.
1/2. So I need to multiply what row times 1/2?
The top row.
It's a top row. So when you're making the 1, you multiply the row you're trying to make a 1. So 1/2 times row 1. So 1/2 times 2. Then we jump over. 1/2 times who? 1. We draw the line and it's 1/2 times 1 again. Do we do anything to row 2? Yes or no? No. Very good. So the math, we don't do anything to row 2. I'm going to go ahead and copy that guy because to feel fulfilled like I did something, we just copied. That's it. We brought it down because you didn't do anything. Half of 2 is? 1/2 times 1? 1/2. 1/2 times 1? 1/2. So it says you first make the 1 in that row, and then what do?
Multiply by the
We did that part. But after we get the 1, we have to make, what's the next step? The 0. Who needs to become a 0? The 3. So we multiply the row with the 1. Who has the row? Who has the 1?
Row 1.
Row 1. What do we multiply row 1 times? What are we trying to get rid of? We're trying to make this a 0, so I need to do what to the 3? Subtract 3. So I subtract 3. -3, because that means that's like a subtract 3, times row 1 plus what row? Row 2 equals to the new row 2. So we multiply the one that has the 1 times the number that we're going to use to get rid of this, which is a -3, and we need to add it to that row. And I believe, isn't that what it says? If we read it, let me see. To make a 0, you multiply the row with the 1 with whatever number it's going to make it a 0 times the -3 and add it to the row you want to make a 0. I want to make this row a 0 for right now. So when I do, does my first row change? No. So -3 times who? 1 plus 3. Very good. Space. -3 times?
Okay.
1/2 plus 2. -3 times 1/2 plus a -2. Now, when you end up with fractions like this, it is recommended that you have your calculator. You could use your calculator, so use it to save you from the chaos of having to do that in your head. Now, once again, did I change my first row? So I'm going to copy that one down. Now, what's a -3 times 1 plus 3? And you just type it into your calculator like that. Now, my recommendation to you is to keep the numbers as fractions. So you just type it like this: -3 parentheses 1 close parentheses plus 3, boom, 0. Now type this into calculator: -3 parentheses 1 divided by 2 close parentheses plus 2. It's going to give you a decimal. You go to math, enter, and it changes it to a fraction for you. which is a 1/2. -3 times a 1/2 plus a -2. Math, enter.
-3.5.
You do that, what?
Enter.
-7.
-7/2.
Wait, okay, then I'll take that.
So, no, -3.5 is
Oh,
this,
okay.
but change it to a fraction. Just change it to a fraction because when we have to multiply by a fraction, by a reciprocal, it's easier to do that. All right, so
I'm not getting how you got -7/2.
can I see your calculator? Where? So it's because it's a -2.
Okay.
So -3 parentheses 1/2 minus or plus a -2. Bam. You see the -3.5?
Mhm.
Math, enter. And sorry, I hit the wrong one. There it is, -7/2. Alrighty, so we find there. I got my 1, I got my 0. Now I have to make who? Who's my next job?
That 1/2 of 1.
The 1/2 in the bottom has to be a 1. And how do we make that? Multiply by the?
Reciprocal.
And who's the reciprocal of 1/2?
2.
2. So we do row. What row are we multiplying times 2?
2.
Very good. 2 times row 2 equals my new row 2. Beautiful. Not doing anything to the top. So 2 times 0. 2 times 1/2. And 2 times -7/2. So my answers here, the first one stays the same. We said there was no change to the first row. So you already told me that's 0. This is a 1, and this becomes a what? What's 2 times -7/2? -7. So I have completed Gaussian elimination. Oh gosh. Yes? Yes. So from here, remember, if I had to solve it from here, I have 1x plus 1/2 y equals to 1/2. Are we good with that? But I also know that, who's this again? Y. Y equals what? -7. So you already know one answer, but you're still looking for x. So where do I put this in?
Mix it.
So I have x plus 1/2 times -7 equals to 1/2. 1/2 times -7 is -7/2. And then what do you do with that -7/2? You add it to the other side, and when you add 7/2 plus a 1/2, you get 8/2, which is 4. So this is your x. So my answer is 4, -7. So remember, when you just stop at Gaussian elimination, you still have to do this. But if you didn't want to do this, then you continue with what? To finish Gauss-Jordan. So, question.
If we did that, it would make the 1/2 into a 0.
So to do that, we need to make the 1/2 into a 0. So how do I make, if I have half, I need to end up and do what? To make it a 0. So this is, I know that's the easiest thing to do, but remember the rule says multiply by a non-zero constant. You could never multiply by a 0. So if I have 1/2, how can I get rid of a 1/2? Subtract 1/2. But that subtract 1/2 needs to be multiplied times the row that has the 1. Who has my 1?
This row 2.
Row 2 needs to be multiplied by who? What kind of 1/2?
Negative.
-1/2. A -1/2, and we add it to who? we added to row
One.
1. And that's going to become my new row 1. Am I changing row 2? You're only changing who? Row 1. So negative 1/2 times row 2 plus row 1. Negative 1/2 times who? 0 plus 1. Negative 1/2 times who?
1.
1 plus
1/2.
1/2. And negative 1/2 times negative 7 plus 1/2. So remember, this is going to be my final answer here. I didn't do anything to the bottom. Half times 0, 0 plus 1, 1. Negative half times 1 is negative 1/2 plus a positive 1/2, 0. Negative 1/2 times a negative 7 becomes a positive 7 over 2 plus a 1/2 becomes 8 over 2, which gives me a 4. And if what I blah, 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 just said, just plug it into the calculator. That's what it is. So x is 4, y is negative 7. There it is.
Is it always going to be the top row being X and bottom row being Y?
It's always going to be column of x, column of y.
And then the third one.
And then the third one, so when we did this, just so we know, you're saying x equals blah, y equals blah, z equals blah. X, y, z. So that's where your 1 is. All right, I want you to try one. So that means you write down the first step. Wait 20 seconds for everybody to write down the first step they would take. I would write it down to see if we agree, if it would be the same, and then you do the operation. So for C, x minus 4y equals to 9. 2x plus 5y equals to 5. So write it down as a matrix. So did you write it as a Did you write a matrix? 1, negative 4, 9, and 2, 5, 5. Did you write down the first step that you would have to do?
This is the goal to make the 2 a 0.
Very good. So this is already a 1. We have to make this a 0. So tell me the equation that would make that a 0. Write something down. Worst thing is you're wrong. As soon as I write it down, you're going to erase and you're going to write the right one. Not yet. I want everybody to at least have people who are scared. No scourds. Write down an equation. How do I make this 2 a 0? How do I make that 2 a 0? Okay, so this, what would it be, Dane?
I thought I knew it, but I didn't.
It's okay, well tell me. If it's wrong, I won't write it down.
No, I genuinely have no clue.
Wait, would it be
Negative
negative 2R2 plus R1 equals?
Negative 2 times R,
1.
1.
Oh,
plus
R2
equals
equals R2.
2. Yes. So you do -2, because remember, you're going to multiply times the row who has the 1. That's what it says. Multiply the row that has the 1, and then you add it to the one you want to change. Multiply to the row that has the 1, and then, so go ahead and do the work. Or show the steps. So which row is the one that's changing? Row 2. Very good. Did we finish it? Did we multiply it? Did we get the new matrix? No, I know. I already have it, but I'm not unpausing it. So show the math that -2 times this plus this, -2 times this plus this, -2 plus, and then actually solve it on the side. All right, so this is what I have. Check your work. Does this look correct? -2 times row 1 plus row 2. -2 times row 1 plus row 2. 2 times -4 is a +8, and 8 plus 5 is 13. Oh, the -13? -2 times 9, it's -18, plus 5 is a -13.
I keep doing it and plugging the wrong numbers.
So you just need to go slowly. -2, row 1, bam, plus this.
Okay,
Negative
there's two
2?
numbers. There's 3 numbers in row 1. How do you know which one you're supposed to?
You're
put?
doing one at a time. 1, -4, and 9. You have to do it to each. 1, -4, and 9. Yes,
Why
sir.
do you need that one, like that one column, just, out over there,
Which column?
left? Yeah, that one. I
Here?
just don't understand
Here?
that. Yeah.
This, because I'm not changing row 1. My intention is to change this row. So row 1, this is still going to be a 1. This is still going to be a -4, and this is still going to be a 9. I'm just copying it down. We're not doing anything to that one. The reciprocal is, if it's a whole number, you put it over 1 and you flip it. Reciprocal is flipping the fraction. That's what it is. So write down the next step. You're trying to make who a 1?
13.
This, yeah, because remember, your goal is 1, 1, 0 number. This is your goal. You already have that 1, you already have the 0, boom, boom. This is my next goal, to make this a 1. But if it would have been the -4, you would have done a -1, 4. Okay? Just to answer that question about the negative. So for this one, the plan is to make this guy a 1. To make the 1 is a 1/13 times row 2 is your new row 2. So you don't do anything to what row?
Row 1.
Row 1. 1/13. Let me freeze it. You work on it. My hands stay there. It's all good. It's good. Thanks for an old tube.
Which number are you up to?
Everything. All of them. I know I can. I know I can. Choo, choo. Now this one, finish it all the way to Gauss Jordan. So after you do that, you still have to make that -4 into a what? 0. Oh, I'm sorry. So when you finish that, this is what I'm hoping you got. Sorry. Is that correct? Okay, so then finish all the way Gauss Jordan. So we need to make this into a 0. How do we make this guy a 0? You multiply the row who has a what? 1. Multiply the row. So in this case, which row has a 1? Row 2. Because you multiply, because remember, you're working with this column because you're trying to make that 4. So in this column, which row has the 1? Row 2 to make that one. Because you could only use that one to make that a 0. So write down the little operation here. So write something that would help you make this guy into a 0. In 10 seconds, I will write it. Or somebody give it to me. And what is it?
-4 times row 1 plus row 2 plus row 1.
I do add row 1, and it does equal row 1. But once again, which row am I multiplying? By what?
1, 4.
A positive 4. Because remember, it's a -4. So how do you make a -4 into a 0? By adding 4. So 4 times row 2 plus row 1 equals to row 1. It's something that's going to take practice.
I understand.
Yay?
Yeah, I understand something. I think about it. Like the X and Y.
What'd you get for X?
5. And then Y is the other one. Right?
Yeah.
Oh,
So you have to get rid of -4?
Huh?
I'm confused. The reason I get rid of it?
4.
Oh, I just had to take it all the way to Gauss Jordan. You could have. What? We're making the -4 into 0.
So the -4 goes from the R1 spot?
For this part?
Yes.
Yeah. So which row doesn't change?
Bottom row.
The bottom. 4 times 0 plus 1. 4 times negative. Oh, just kidding. 4 times 1 plus negative 4. 4 times. So, are you okay?
Not confident.
Not too happy, but we're okay.
Oh, sure.
Hmm?
Oh, sure.
Oh, sure.
Yeah.
Okay. Alrighty. Ready for a 3x3?
No.
Yes. Yeah, we are. A 3x3, we're just gonna do the Gaussian. We're not gonna do the Gauss Jordan. And just by doing the Gaussian, it already takes a whole sheet of paper. Because it's more. So, ready. My name is Freddie.
I have a question.
Yeah, sir.
I know it says a digit on the phone. When is this right
Oh, I don't know. We'll think about that later. Okay. Take off points from a test for that question. Example number 2, we are going to do 3x3s, which means XYZs. So this is a problem. 2x minus y plus 4z equals 2a negative 3. X minus 2y minus 10z equals 2a negative 6. 3x plus 4z equals to 7. There's no 1. So our goal is to make it look like that.
If there's no number,
Huh?
if there's no number, you just please don't. Or you just put a-
For here, you'll put a 0. So my matrix, 2, negative 1, 4, line, negative 3, 1, negative 2, negative 10, negative 6, 3, 0, 4, and 7. Are we good?
The same rules, so this one,
Huh?
the same rules.
It's the same rules, but you need to look for stuff. Now, if you recall, I can't flip the page, but when we wrote down these 3 rules, the first rule says you could what?
Interchange rows.
Interchange rows. Why would you want to interchange a row? Do you see something there that would benefit if we interchange a row?
Second row answers for one.
So
Yeah.
one,
The second and the second, first and second.
The first and second, if we interchange them, if this one comes to the top, this one comes to the middle, you already have your who?
For one.
Your 1. Boom, there it is. Now, I'm not saying that if you don't take that first step, you're gonna end up working and it's gonna be wrong. But you're already, because if not, what would you have to multiply this by? A half. And that's already gonna, and I'm not saying that's not gonna be the case. We're gonna end up with fractions right now. But first thing we do, and I'm wondering if everybody heard, what are we gonna do?
Switch the first and the second.
Very good. Interchange row 1 and row 2. Row 1 and row 2. So my new matrix is going to be 1, -2, -10, -6, 2, -1, 4, -3, 3, 0, 4, 7. Woo. Okay. Great. So, what do we do next?
For us to multiply this by
We have to make this a who?
0.
A 0. So we multiply the one, what row are we going to multiply?
The one with the 1 in it.
And which is row 1. What are we going to multiply row 1 by?
-2.
-2 times row 1 plus row 2 equals my new row 2. So who's the only row that's changing? Row 2. So I'm not going to write anything on top or anything in the bottom. I'm only doing my work in the middle. -2 times 1 plus
2.
2. -2 times
-1.
negative
-2.
2 plus
Negative.
-1. -2 times -10 plus
4.
4. -2 times
-6. Plus -3.
So my first row did not change. My last row did not change. But my middle row is all going to change. -2 times 1 plus 2 is -2 times -2 plus -1 is 3. Because this is a positive 4 minus 1 is 3. A -2 and a -10 becomes a positive 20 plus 4,
24.
24. -2 times a -6
Plus 12.
plus a -3,
9.
9. All right, first thing.
93 wrong.
Now we need to make this
What do you make that for?
0.
a 0.
But
So-
you do
You
it
work by
too.
column.
You work by columns, yes. So make it a 1, 0, 0. And the other one, as soon as we did this one, we jumped to that one. But 1, 0, 0, and then 1, 0, and then a 1. So who do I need to multiply in order to make this a 0?
Row 1.
Row 1, -3. Very good. So I have a -3 times row 1, and I'm going to add it to which row this time?
Row
Who are we changing?
3.
Row 3. Very good. So we don't do anything to the top and the middle. -3 times 1 plus 3.
3.
-3 times
-2.
2 plus 0. -3 times
-10.
plus
4.
4. Line. -3 times
-6.
6 plus
7.
7. So the first two rows don't change. We just bring them down from here. So negative 3 times 1 plus 3 is a 0. Negative 3 times a negative 2?
6.
6 plus 0, it's just a 6. Negative 3 times a negative 10
Positive 30.
plus 4.
30.
3, negative 3 times a negative 6 is 18 plus 7,
25.
25. How are we feeling with that? So I got my 1, I got my zeros. Next, I have to make who a what?
The second column, that 3 on 1.
The second column, the 3 of 1. How? 1/3. 1/3 times which row?
Second.
Row 2 will give me my new row 2. So I hope you notice when you're having to change the 1, all you do is just a multiply. When you're having to make a zeros, there's a multiply and an add. A multiply and an add. So only row 2 changes. 1/3 times 0. 1/3 times 3. 1/3 times 24. And a 1/3 times 9. So first row doesn't change. Bam, 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 bam. 1/3 times 0 is
0.
1/3 times 3 is 1. 1/3 times 24 is 8. 8, close, close. 1/3 times 9 is
27.
3. Because remember, it's 3 divided by, it's basically 9 divided by 3, 24 divided by 3, 3 divided by 3, and so on. This one did not change. Okay, so I got my 1, 0, 0, my 1, but now
That 6 need to be a 0.
that 6 needs to be a 0. So to make a 0, multiply and add. Multiply by
Negative 6.
negative 6 times row 2 and add it to row
3.
3. Very good. So the only row that changes is the 3rd, right? First 2 rows, nothing happens. 1, negative 2, negative 10, negative 6, 0, 1, 8, 3. Negative 6 times 0 plus 0 is 0. Negative 6 times 1 plus 6 is negative 6 times 8, 48, plus 34, negative 14. Negative 18 plus 25 is 7. And remember, once you write this down, you just type it into the calculator and it gives you your answer. So 1, 0, 0, 1, 0, but
That negative 14.
so what do I do with that negative 14?
Just multiply it. Turn it into a 1.
Negative 1, 14. So if it's a negative, you have to multiply times a negative. So all row 3 gets multiplied by a negative 14. Negative 14 times 0. Negative 114 times 0. Negative 114 times negative 14. Negative 114 times 7. First rows, nothing happens. 0, 1, 8, 3, 0, 0. What happens when you do a negative 114 times a negative 114?
Zero.
It becomes a
Power.
positive 1. And a negative 114 times 7 becomes a negative 1/2. Now, this is us finishing Gaussian elimination. But if you have to find your 3 answers, so can you help me write down the equations from here?
X
X
minus 2
2y
y
minus
10 z
z equals 2a. Very good. And then
z
not y
Plus 8
equals
equals 3
and then
z equals negative 1/2.
so I already know this guy. Yes?
Yes.
I can plug it into the one right before. So this becomes y plus 8 times the negative 1/2 equals to 3. And what is half of 8?
4.
And it's a negative 4, right? And then what do I do? Add the 4, and I get that y is 7. So now I know my z, now I know my y, and you plug it into the first one. And the first one says x minus 2 times y, which is 7, minus 10 times z, which is a negative 1/2, equals to a negative 6. What's 2 times 7?
13
What's a negative times a negative? And it's half of 10
plus 5.
plus 5 equals to a negative 6. This becomes a negative 9. And then we add 9, and find out that x is 3. So my answer here is 3, 7, negative 1/2.
That's the final.
That would be your final answer. Like, the point is for you to find out who your x, y, and z are. That's the point here. All right. So, is it as terrifying as the first when you did the first problem? Not quite as terrifying because you have, okay, I get that part, maybe I'm still missing this, but you get more than the very first problem. That's what I need for it. And this is going to be the hardest thing. After this, the next lesson is going to be a lot easier. It's not going to get, like, it's for you, but you need to understand how to do this because you're going to have a problem, 1 2x2 and 1 3x3, where you have to solve this way on the test.
How
Yes.
about on the final?
Well, I don't know about the final because it's multiple choice and I have not seen it or know what it looks like or anything like that.
So you don't make it?
I don't make it. It's a department final, so whatever they give me. But they did tell me today it is multiple choice, but it doesn't mean it's going to be easy. Like if you make a tiny mistake, you're going to get one of those wrong answers. I would,
Negative or something.
yes. So, you want to try one on your own?
No. We'll be here for a while.
Wait. Now, really quick, would this be an interchangeable one? Do you do the interchanging in this one, yes or no? No, because your first row already has a who? A 1. Okay, very good. So let's do that part. All right, so you don't interchange because your 1's already a 1. So what is the first thing you need to do for this problem?
It's on your
Well, tell me
Making
and put it on
to a
paper.
0.
Yes, make it to a 0. Do it. Figure it out. And you might get some fractions towards the end. Your final answers are whole numbers, but you get fractions while you're doing the work. So we're trying to make that 2 a 0. You make the 2 a 0 by multiplying the row that has the 1 plus the opposite, basically, of what you see there. Opposite of a 2 is a, and then add it to that row you want to make a 0. So I'm hoping that's the math thingy that you got. Actually do it, please. So I did the first one, and that's what I got. Once you're done with the first one, type it into, see if your first one is correct. Yes? Good. Now we got to make that 3 also a what? A 0. So go ahead and do it. Did everybody write the next thing that you have to do in order to make that 3 a 0?
Yes.
Yes, so I could unfreeze it and you could check. Yes? Okay. Good. Now I'll do the math. Type, type, type into the calculator. So once you're done with that negative 3 times row 1 plus row 3, here's the matrix you should have gotten. And now we have to worry about making that negative 5 into a who? All right. Dun, dun, dun. And that one's an easy one, right? The ones are easy. And it's what times what?
4/8.
Negative 1/5 times?
It's not positive.
You're trying to make it into a positive one. So that's why it's a negative. Because if not, it would make it a negative one. The whole row, yes. And you're gonna get some fractions, but like I said, you have a calculator, use it, please. And keep it as a fraction, because some of those, like if you change it to a decimal, the decimals are redunculous. And that might make it a little bit more confusing. So always go math, enter, and change it to a fraction. All right, so we're there. I'm hoping. Next thing is we make who a who? The 7 is 0. The negative 7 is 0. So do the little math equation that you think it would be. What's going to be the math equation that's going to make that negative 7 a 0? What will be the math equation that makes that negative 7 a 0? Which row do you have to multiply?
The top row. Row 1.
So we're gonna use the second one.
Row 2.
Why would you use row 2?
Because
1, 0, 1.
this is the one you're trying to make a 0. So where's the 1 on this row, on this column? So remember, when you're making these zeros, you use this row 1. When you're making this guy 0, you're going to use row 2, because that's where the 1 is at. And then add it to row 3. So there it is. 2 times row 2 plus row 3 equals your new row 3. And after that, we just have one little thing left. And you're going to get fractions, but remember, it's okay. So then this one, what do? We have to make that one into a what? Into a 1 by multiplying everything there times -5 over 31 times row 3. So -5 over 31 times 0, -5 over 31 times 0, -5 over 31 times -31 over 5, and -5 over 31 times 62 over 5. One, two, -3, and 9. 0, 1, -8 over 5. And what does this become? A -2. So after that, it should not be bad for you to find out who your X and Y are. Man, I see all the happiness in your faces, guys. So those of you at home, y'all didn't miss much except for all this.
Especially when you look over there and it says 10 o'clock, you're like, man,
But
really?
it's not 10 o'clock. I'm like, what? All right, let's just finish this off. I know that this becomes X plus minus equals to 9. Y minus 8 over 5z equals 26 over 5. But I know that my beautiful z is a -2. So you already have one answer. I use this and plug it into the one right before it. Y minus 8 over 5 times a -2 equals 26 over 5. This -8 and the -2 becomes a positive 16 over 5. And what do I do with this 16 over 5?
Subtract.
Subtract. And what is 26 minus 16? 10. And what is 10 over 5? You see? It looks scary, but guess what? I know that my y is a 2, my z is a -2, so we plug it into the first. X plus 2 times 2 minus 3 times -2 equals to 9. X plus 4 plus 6 equals to 9. X plus 10 equals to 9. And then we subtract 10. Subtract 10. X is a -1. -1, 2, -2. So, crazy a little bit. Before you leave, and that's going to be it for today, and it's only 9 o'clock, so I still have 20 of your minutes, 2:20, hopefully. But I'm going to give you a post-it of all the work that you're missing. And this goes for everybody at home, if you actually watch this video. You guys need to understand, your grade looked very beautiful because all the assignments that you had not done, it just said past due, past due, past due. And a lot of you were like, oh, I have a 70 and I haven't done squat. I went and I said, replace all the assignments that haven't been done with a 0. And a lot of people went from 80s to 40s. Just letting you know. So if you're not sure what you're missing, I'm going to give you a post-it. But some of those are closed because they're from the very beginning of the school year. I am not going to open them until I see some interest and you come and visit me and say, Miss Peña, can you please open my 5.5, 4.5, 4.3, 4.2, and I'm going to give you a week to work on them. And if they're not done by that week, that means you don't care, and I'm not stressing. Got it?
Can I have my groceries so I can leave? I gotta go.